AIoT. That stands for AI for the Internet of Things devices. And that's what I want to talk about today. So what kinds of AI does AIoT need? Well, we can use generative AI in a few cases. And there's a lot of people here at the expo call talking about generative AI this, generative AI that. It's cool technology, and in the right cases, it's a great technology, but it's not everything. AI is bigger than GenAI. It is much bigger than it, and I want to take you through that a little bit today. This is a cool chart from Gartner. It's a recent chart. You can see on the rows on the left-hand side are various use case families. And in the middle column with the colors are how useful generative AI is to that use case family. You can see at the bottom there, if you're doing content generation or user interface design, generative AI is cool. Use it, have fun with it. It's the right technology to use. But if you're in this yellow section where you're doing segmentation or clustering or recommendation systems, not so hot, not so good. And in particular, if you're in the red section with predictions or forecasting or design intelligence, decision intelligence, it really isn't the right technology to use. So if people are telling you you need to use Gen AI for everything, don't believe them. So when should you use generative AI? Well, if you're trying to do those use cases in the red or yellow section, you're adding more risk to your project above and beyond hallucinations of the LLM itself, because the technology just isn't appropriate for that. So don't push generative AI where it doesn't fit. What you obviously want to do is figure out what technology, AI technology you're going to use and make it fit your problem and your use case. So let's talk a little bit about IoT devices. My name is Dr. Scott Gerard, and I'm from Knowledge Reactor, and this is what I do. IoT is a very important subsection of the technology landscape. The popular press really isn't covering it very well because everybody's focused on generative AI. We understand that. But today there are 17 billion IoT devices that have been deployed worldwide. That's twice the population of the planet. That's a lot of IoT devices. And by 2030, the estimate is it's going to be about 30 billion devices. So there's going to be a lot of focus on IoT in the coming decades. Where would you use IoT, or what devices are there? There we go. You can certainly use them in the homes, anywhere from smart thermostats to smart refrigerators and everything in between. They're putting IoT devices on drones, on cars, and on trains, collecting information about those devices. They're also being used a lot in business in various places. A factory floor will often have many IoT devices on it spread out over the floor so they can monitor what's going on throughout the floor. If you're into precision agriculture, people are putting devices in the fields that measure temperature, pressure, humidity, salinity, whatever information you want to have about your crops, and they're putting multiple of those devices across the farmer's multiple fields so that you can put water and pesticides on the part of the fields that need it and not put it on the parts that the sensors say don't need it. And finally, you can do supply chain where you have a lot of devices in the supply chain, and that supply chain can literally span the globe. So what IoT is bringing you is really the data, and it's grounding your machine learning models, your AI models, in real world data that came from the real world. It's not picking up data from some guy who wrote a blog post somewhere about something, right? Where does the AI fit into this? Well, on the left-hand side, if you've got a single device, which is mostly what's on the left-hand side, AI can look for patterns across time over those devices. On the right-hand side, we've got devices spread out over space, so AI can look for patterns across both time and space. There we go. So this is one of the kind of classic AIoT applications. On the left-hand side, the big thing in the back is a power transformer, 10,000 volt transformer. It provides power to neighborhoods of about 100 homes. My client's client had that device. My client built this device here in the front. That's the IoT device. And what it's doing is it's pulling up 13 dimensions of information about that transformer. What is on the right-hand side here is an anomaly prediction model. So what we've done here is we've taken 2 of the dimensions of the 13 and put them on the XY axis. The other 11 dimensions are squished into these little towers. The interesting point here is that the machine learning was able to look at those 13 dimensions, look at this complex shape, and figure out which of the 1/100th of 1% of the events were actually anomalous. I defy you and I defy me to do that kind of work manually. What we need to do here is to use these machine learning models as the device ages, as the device is repaired, and as the device is replaced. We can rebuild these models over time quite quickly. These devices are like $20,000 a piece. They're powering, there was like 43 of them deployed, so we're talking millions of dollars at stake here. And if one of them goes dark, the whole neighborhood goes dark. So that's why we're trying to compute these anomalies as we go. This is another picture of, this is an elder care application. What's happening here is the red line is a picture of a simulation of a person walking through this house. The green circles here are sensors that have been in the house. Now these aren't great sensors, but they're noisy and they're faulty. Sometimes they fire when they shouldn't, and sometimes they don't fire when they should. But using an MC-MC algorithm, integrating the sensors across space and across time, we're able to compute that pink cloud. That pink cloud is a probabilistic cloud of where we think the person is at a particular point in time. The nice thing about this is the first analytic in probably a chain of analytics. Its job is just to figure out where is the person. We don't have a lot of sophisticated sensors here. If you had to do this again today, we did this about 8 years ago, you would use better sensors. But every sensor is faulty to some degree and is noisy to some degree. But these analytics help us address the uncertainties statistically in a precise way. I will also mention that because the baby boomers are aging out, the population is getting much older, much quicker. All of you young people are going to have to support people like me, and so I'm trying to help you do that better. But we're talking about potentially trillions of dollars to be saved. If we can keep elders in their homes for an additional 2 years, there's a lot of money that could be saved, and that's where they want to be in any case. So if this is interesting to you, my points are really IoT is a growing area, and using AI to make decisions about that IoT data is very important. IoT is widely adopted and exploding. There's many kinds of AI that can be applied to AI. Some of them are generative AI in a few cases. If you're interested, stop by and we'll talk about it. But there's a lot of AI that doesn't fit the parameters of generative AI. And so other algorithms are needed, like I've tried to demonstrate here. So we're running a show special of 20% off. If this is interesting, either contact me after the presentation here or come by my booth at K41. Thank you for your time.